Hello students, welcome to e-learning. Now we are going to calculate moment of inertia using the same previous question in the previous video. From the previous video, the question need to be corrected. The top flange is 150 by 15, web is 15 by 27 millimeters, and bottom flange is 150 into 38 millimeters. Determine centroid and moment of inertia. Okay, so first we have calculated already a1 x1 y1 for section 1, x2 y2 and a2 for section 2, then a3 x3 y3 for section 3, that is bottom flange, and x bar and y bar is 75 millimeters and 171.59 millimeters respectively. Taking these values, we are going to calculate moment of inertia. So first of all, we know we have to use theorem of parallel axis. So moment of inertia for section 1 about x axis is given by BD cube by 12. So B is 150 into D is 15 cube divided by 12. So 42187.5 millimeter raised to 4 is moment of inertia for section 1 about x axis. Only section 1 moment of inertia we have got about x axis. Now only y axis for section 1 moment of inertia. Okay, so the formula is dB cube by 12, reverse of BD cube by 12, right? So here it will be 15 into B is 150, B cube by 12, it is 4.218 into 10 raised to 6 millimeter raised to 4. So these two are moment of inertias about x and y axis for only section 1. So section 2, that is web section, B is 15 and D is 270, right? So BD cube by 12 for section 2 moment of inertia. So 15 into 270 raised to 3 into divided by 12, 24.603 into 10 raised to 6 millimeter raised to 4 is moment of inertia. About y axis, the moment of inertia for second section will be dB cube by 12. So D is 270, B is 15 cube divided by 12, 911.25 into 10 raised to 3 millimeter raised to 4, right? Now coming to section 3. Section 3 moment of inertia is BD cube by 12. So B is 75, D is 15. So 15 raised to 3 divided by 12, we are going to get 21093.75 millimeter raised to 4. And section 3 about y axis moment of inertia will be dB cube by 12, that is 15 into 75 cube divided by 12, 527343.75 millimeter raised to 4 is the moment of inertia. So combining all these moment of inertias of respective sections in main formula of moment of inertia of whole section, right? So we know the formula, parallel axis theorem, that is moment of Ig plus AH square, right? So AH square, so area 1, area 2, area 3 is been calculated in the previous slide during CG. Those values you have to put it here, and Ig1x, so you can see here it is Ig1x, here it is Ig2x, here it is Ig3x. So we know that is Igx is given by Ig plus AH square, right? So first we will try to understand Ig plus AH square is the formula. So here H square, everywhere this H is calculated, that is y1 minus y, y1 y minus y2, y minus y3, Yes or no? So these three, how to calculate, we are going to understand here. Now coming to, excuse me, coming to ig 1x, we have given plus a1 is mentioned. So how to calculate h square for section 1? So main CG lies at this location, right? And section 1 ig is here in the center of that section 1. So we know that y bar is known, that is this is y bar. So y1 is from top to bottom here, from the center of this section to bottom. So y1 minus y bar will give you that value h1 square. Okay, so this is going to be a1 square h1 square, right? And this is going to be ig x1. Yes or no? So which is put. Next, in section 2, this is going to be ig 2x, and this is going to be area 2, and this is going to be h2 square, right? So h2 square, how to find out this h2 now? So we will try to understand h2. So main CG lies here, h2. This point is indicating the CG of that particular section, section 2. So we want only this difference, right? We know this is y bar till this means main, and this is y2. So y bar minus y2, you are going to get the difference, this distance, the required difference, right? So y bar minus y2 distance, and this y bar is nothing but the center of gravity calculation answer, and y2 is the one of the calculation in CG. So in the previous slide you are going to get that. Solve it. Here it is mentioned 171.59 is y bar, okay, minus y2 is 150. So put that value. Coming to next, ig3, this value ig3x, put that value there. Area 3, you know, y bar minus y3. Now y bar is this distance, right? And y3 is center, from the center till the base reference, correct? So center of gravity is here of the third section, and the base reference, that is thickness by 2, 15 by 2, that is 7.5. So we want only the distance from CG of third section to main CG. So this is y3. So y3, y bar is 171, you can see it here, 171.59 minus thickness by 2, that is 7.5. So yeah, that is h3. So putting all these values, you are going to get moment of inertia of whole section about x axis like this. If you want to get moment of inertia of whole section about y axis, you have to put ig 1y, ig 2y, ig 3x, and areas will remain same, a2, a1, a3. Then only here you have to replace with x bar minus x1, x bar minus x2, x bar minus x3. Put those values, get moment of inertia about y axis. Okay, so this is how you have to find out moment of inertia. So thank you for listening. For further notifications and upcoming videos, subscribe the channel, like, share and comment the video. Thank you.